Okay, I think we'll get started now, if that works for you, Manny. Okay, welcome to the session this morning, everyone. We have several exciting talks. We're going to hold all questions till the end of all the talks, I think, right? Yeah. Okay, great. So with that, I'm happy to introduce Manny, who's going to be talking about some work she led out of a Como School activity on flooding in Pakistan.
So hello, I'm Manny. That's my preferred name, but like on paper is Pui Man. So actually I'm a PhD student from ETH Zurich in Switzerland. And my background is actually I'm a atmospheric climate scientist, and now I'm working for the risk modeling for internal displacement risk. So I'm also collaborating with Internal Displacement Monitoring Center in Geneva. So yeah, this project, it was originally a group project from the Como training school for the compound events, but the project like iterate a multiple version, and now we've taken out all the compounding risk in terms of the modeling realm, because it's not really like able to be modeled with any model at the moment. So here I'm just talking about how we approach the problem using the model Climata, and I'll talk a bit more in the next slides. So a quick recap of the Pakistan flood. Maybe all of you already remember like this massive flood in Pakistan that causes a lot of damages in the livelihood over there. And well, here's just a quick recap, but for me, I only look into the last line, how many people being displaced. That's the number that I concerned for this project. So the objectives here, I'm using Climata, is actually a risk modeling platform that is open source and Python based, that is being developed in my group in Zurich. And here I'm using the Climata, and I'm trying to use a generalized top-down approach to try to estimate the displacement risk. And here I'm just actually using the Pakistan flood as a case study to really explore how much potential and limitation of this kind of approach. So previously, I also used Climata to compute the global risk of displacement risk for flood, but it's a global scale, and I'm also working on a global impact forecasting for tropical cyclones to displacement. But here is just a really an in-depth focus on what the model can resolve. So a basic idea of the Climata platform is actually following the standard framework of the risk calculation. So there is just a platform that combines the flood hazard, exposure, and vulnerability, which is a mathematical function that links the intensity of a hazard to the exposure. So here the flood hazard, I just used the accumulated flood deaths in the Pakistan as actually computed by my other work colleagues. And exposure here, I just defined, I'm just using the word pop layer to have the population distribution in Pakistan. And the impact function would be how many percentage of people that could be displaced with regard to the flood depth. So that's the hazard intensity that I'm using. And there I just combined with a Climata platform that gives the displacement risks. That's the final output. So in this talk, I'm also will be mainly focused on the vulnerability. So before that, to also understand, I mean, it's modeling, we need data. So here is just a quick cap of the data that I have. So the study area is actually quite limited to the Sindh province. So it's on admin 1 level. So there I actually able to find a provincial government disaster report, a situation report that gives approximately how many people that are being displaced in each district. So district is an admin 2 level. That's an example. That's the SBA over there is one of the districts. So in the Sindh province, there are in total 24 districts. And from the government report, there's already 7.5 million people that recorded to be displaced. IDMC gave the number of 7.6 for the whole country. We will discuss it later about in general, the data and also the modeling realm. So yes, as I said, the focus will be on the vulnerability, because I mean, I'm sure many of you here would know better than me, when you talk about displacement, all the driver processes, there's many of them. So it's just a photo that I like that kept from the World Attribution Study for the Pakistan flood. they note down many drivers of what can cause displacement. But for me, like my approach is I generalize all of these drivers with a more simple mathematical function and plug into the model. So what I do is actually on the right, like the black and white functions. So before like moving on to the whole modeling realm, I just want to note that like people may doubt that the vulnerability approximation is a bit too generalized. And here I just want to say like, yeah, we also generalized the hazard approximation. So I just listed like 3 flood characteristic that could affect the impact. Of course, the velocity matters, the depth matters, and also how long it's being flooded matters to the impact. But here I also just want to state that in the modeling practice, we also generalize it into just the accumulated flood depth that's being used here. So everything is generalized, and we try to give some output and estimation out of it. So this is one first result on that I'm actually throwing as step functions. So step function means that I just assume all the people in the grid cell that are being displaced when the flood depth is reached certain threshold. So here I just did a test run with a threshold of 0.5 to 2 meters. And the range is actually just representing this, like the range of the number that could be displaced by this threshold. So I plotted in this log scale graph, and with a PDMA, so the government reported number laying on top. Well, I mean, yeah, I don't know what to say with this graph. It seems like still able to capture some of the district, but not all. It seems to have a bias of underestimating in the high number of displacement, but like overestimating the low number. And the total, it's, well, kind of okay-ish, I guess. So this is just a first project, the simplest function that I can plug in. And yeah, that's the SBA, just to note the district again. So that's a simple approach, but like the next step, what I'm trying to do is using a sigmoidal shape function. So the reason of using sigmoidal function, it's well, just because it's widely used in the impact study. So I just tag it, and there also I try to calibrate a sigmoidal function that best fit to the data that I have. So here just I take an impact function from Carolynne manual for the triple cyclone. I just took the shape and also the underlying governing equations, and there's like 2 parameters that worth noting. The first is the threshold. So the D thresh is the depth of the water threshold when we assume that impact starts again. And here I just choose 0.1 meter, like 10 centimeter. I assume there might be displacement start to occur. And what I'm calibrating is the D half. So D half represents the depth of the water when there is 50% of impact occurs. So this is just a parameter to govern the shape, the steepness of the sigmoid function. And this only one parameter that I'm trying to fit into the data and trying to see if I can come up with one function to generalize the Sindh province. It's also a method quite widely used in the impact modeling community now, and I'm plugging in here. So on the right, you see that's basically the calibrated result. I mean the function stack shape of the 24 district, and the blue line is the overall best fit for the Sindh province. And you see, actually, I just want to state that there's a huge range of the possible shape, and that is kind of the uncertainty captured by the model. I haven't done anything further from this yet. I'm still thinking if I should put like a more fancy calibration method, some optimization, but I don't think it affects the storyline that I'm going to talk next. But yeah, why not with some fancy calibration and machine learning on this? So a quick discussion of all this approach. So here, like the first thing I just want to state that we use this type of impact modeling, Climata, to attempt to quantify the displacement risk and using a very generalized impact. And the key reason why I'm using such a generalized method is because like it's a methodology that's easier to understand by people, and also that I can replicate the same methodology any other places in the world. So actually, as I said, I'm doing global modeling, and I want to be able to compare country A to country B. And with that, I really have to use a much simpler approach to do that. But in this approach, I also have to state that it's it's highly dependent on the data quality, which I'm also kind of struggling time to time, not just on this project, because displacement data, I like, for example, displacement data from IDMC that I know the best. Just the term displacement, it can mean evacuation, it can mean long-term displacement, housing damages, and like even within one institute that collect all the data, they also have the problem of not able to harmonize all the data across different country, because they just collect data from different government report and they have different, well, attitudes in collecting data, also definition. So there, when I use the data to calibrate my model, then it's a challenge, basically. So it's very context dependent on what the data reflects. And the second thing that I want to say is, so in this model, like you can see, I only consider direct impact. So I only compute that people being displaced if there is flood in that grid. But of course, like there's also the cascading effect or indirect impact that drive people to be displaced that is not reflected by the model. And also, like another worth to note, actually in the Pakistan flood it happens in like around June to August, there was also a heat wave, like a very big heat wave in May 2022, that also it could be like causing people to be more vulnerable, you know, like there might be attributing health issue, or like the money resources are just gone for the heat and there's not much preparedness for the upcoming flood. And with Climata, we can actually also estimate the impact of heat, but we can only estimate the impact of heat or flood as independent events. And currently there's still no algorithm or whatsoever to combine both of them. There's a bit of a limitation, but yeah, maybe at some point we'll find a way to do it. And the third thing that I want to start, like, so now you've seen all these modeling approaches, you know what it can be done, and also the limitation. So it's a general question, then how are we going to use these results? So it's also a bit of a question to you guys. And for me, like what I see, the very first thing that come into my mind is like, okay, I still can use it for the impact forecasting. So actually me and my colleague of mine, we are working on the impact forecasting so I'm working on the tropical cyclone displacement risk and he's working on the flood. And still, like, even though the output number is not very accurate, but still, like, we can still give like information on the spatial and temporal forecast of the next few days that might be still useful for the humanitarian organization and also for the resource allocation. So that still can be used, and maybe in the next few years we can establish a model and have someone to verify it. But the second thing is a bit more of a concern. What about climate projections? So I also worked with climate projections before. I computed what's the projected risk of displacement by flood in future. But there I have a problem. None of the results can be verified. I think it's also a bit of an issue with all the model. So model outputs are unverifiable. And how can it still be used? How much we can trust it and make decision on it? So this is also a bit of an open question to you all. So yeah, that's the key messages that I want to say. And here is just some fun fact that along my study of this Pakistan flood. So when I taking all the data, doing all the data shopping, I find data from, of course, the provincial government that gives me all the 24 districts in Sindh. But there's also the IOM report, like a viewed report but they only have like 5 districts in the Sindh area, and I just compared the number and you see it's 4 times less from the IOM. So here is also a bit of a which number should I trust when I do my modeling practice. So what's next? It's also a bit of a message that I've been thinking actually more like generally for my PhD. So now we have this generalized model that is available, that can be used. It's there, the code is out there, you can also download it and play around. And but then what's next? Like for me, like one way to go forward, maybe instead of just going fully data-driven approach, maybe we can make some a priori assumptions of what drives displacement. So basically we assume, like, for example, we assume urban area that's more people of, I don't know, aged or something, therefore they're more vulnerable, and then we give results. Maybe we can go that way. But again, like we have to have a very clear understanding of what's going on. And the second thing, what I'm trying to call is, so now like there's a lot of displacement data from different organizations, different institute. What I'm trying to also like urge is like, maybe we can also do a pooling of the displacement data. If there could be some effort into harmonizing all the data, that would be very useful. So just come thinking of what could be done next. And here, like, that's the end. And I hope that that's an interesting topic, and maybe looking forward for some feedback.
All right, hi everyone, and thanks Manny, that's really interesting and leads quite nicely onto what I'm going to talk about. I'm just going to set up a timer here. You mentioned some of the world pop data, you mentioned flooding and heating, and even at the end there, age and sex, so this demographic component that can be really important for thinking about climate exposure and climate hazards. My name's Andrew Zimmer, I'm a postdoc at Montana State, I work with Cascade. And this is some of the work that we've been really diving into this year at MSU. We're really interested in going beyond just looking at population exposure, but adding a little bit more detail to that and looking at the demographics of certain populations that might be exposed to risks. And so to set this up a little bit, as I'm sure you're all aware, population is increasing and is projected to continue to increase. In November, we passed 8 billion people globally. And that's going to continue to rise up into the future. But not only do we have more people, but we have more people living in towns and cities, from really small towns to mega cities of over 10 million. So at the moment, we're over 50%, and this will continue to rise up towards 2050. So we have more people live in towns and cities, but regionally where this future urbanization will take place is in some of the more vulnerable regions of the world. Projections indicate that Africa and Asia will be the sites of mass urbanization and mass population growth. So we have that on the one hand, we have a lot more people. And when we think about climate change, it obviously is impacting people. When we have more people, that impact is much larger. And so at the same time, we have a changing climate. We have certain risks that we face from the climate currently and from a future climate. This is an interesting article from New York Times where they try to isolate for each pixel the major climate risk. But of course, we all know there isn't just one risk that's facing populations. There may be a main risk, but there are other risks that people face. And risks faced in the United States can be a lot different than risks faced in Africa or Asia. But two of the things that really pop out for me here is the widespread risk of heat stress and the widespread risk of flooding. And often those are kind of co-located if you were able to look at multiple layers. And so we have more people living in towns and cities, but we also have a more challenging climate. And a lot of work has explored how population and climate intersects. And typically this is done by calculating the number of people that are exposed to certain climate conditions. Cascade's work on urban population exposure, Beth Thalheimer at the University of Arizona, looking at how many people are exposed to flood impacts. This is done in rural areas and urban areas across different time periods, but typically just adds a population function, the number of people that might be exposed to dangerous conditions. But we also know that the impact of climate change vary demographically. I did have some highlighting on here that appears to have disappeared. But we know that there are certain vulnerable populations to the impacts of extreme heat and the impacts of flooding. And so when we think about heat and health, older populations can be more vulnerable, younger populations can be more vulnerable. There are also economic impacts for those that are working outside, so that can have the impacts on the labor market and therefore reduce kind of the economy. It can worsen sleep patterns. There are tangible relationships with heat and mental health. When we think about flooding, people can be trapped in place if you have pre-existing health conditions or if you need mobility aids to move out the way of dangerous climate conditions, you could be trapped and therefore exposed to flooding. And so all of these things vary demographically, and not every person is impacted equally by a given exposure. And so what we're doing is using novel demographic data that's available globally to understand how urban demographics vary, but then start to think about what this means for exposure, both to extreme heat and flooding. And so to do this, we use world pop data again. Just going through the example of Nigeria, typically world pop is available with individual pixels that describe the number of people that approximately live inside it. We have 1 kilometer here, but they go down to 100 meter. And it traces cities, and you can kind of figure out the total population of a region or an urban center or whatever kind of spatial unit you might be using. WorldPop have developed a new data set which now disaggregates this total population number into the age and sex distributions. So we know approximately how many males there are, how many females there are, and it goes all the way from age 0, 1, 5, 10, 15, 20, up in 5-year increments to 80 plus. And so we have a really good detailed picture of what the population looks like beyond the total population, what the kind of structure is. And so we use this at 1 kilometer resolution to have a look at some of these climate impacts. And so we can make population pyramids from these. I'm sure there's some demographers in the room or people that are used to looking at population pyramids. But basically it shows you the structure of a population with the age increasing up the y-axis. So we have the number of 0-year-olds or babies every year at the bottom, all the way up to the number of people that are over 80 years old. WorldPop is available annually, so through time, which is how we can animate things like this and see how population is changing. And it really allows us to have a look at demographic structure. And there's a few examples that you might have been familiar with if you've been working with this stuff before. So Nigeria typically has a youthful population. There's a really high birth rate and lots of children being born every year. And so it has a really wide base. There's lots of kids and fewer adults. Japan is kind of the contrasting example, typically is referred to as an aging population where we have a lower birth rate and then kind of a pooling of people in these higher age categories as death rates are typically quite low. And so you can see the number of 80-year-old females in Japan is booming. And then if any of you watched the World Cup in Qatar last year, you might have read in the news about migrant labor building stadiums and being involved in construction. Lots of those coming from Africa and Asia. And you can really see that with the gridded demographic data where this kind of 20 to 45 age group, mostly males, really expands quite rapidly in Qatar. And so this is aggregated, obviously at the national level, but we're able to define different spatial units to have a look at how these demographics change through space and time. And so using these at a finer resolution, we can derive various different demographic statistics and groups. So we can calculate dependency ratio and sex ratio, which are really common demographic metrics. Dependency ratio relates the number of dependents to those that are working, so children or older adults compared to the working population. If that's high, there's a lot of dependents. If that's low, there's lots of people working. And we can also calculate these subgroups of population. So we know approximately how many people live there, but within young, working, and older people, we can kind of isolate these populations and how they're changing. We also have birth rates from this. We have the number of births every year, and so we can calculate birth rates. And then get to a point where we can estimate migration and natural change, which I'd be happy to speak to in more detail afterwards. So we're focused on urban exposure. We know more people are living in cities. We know more people are exposed to dangerous climate conditions in cities. So we overlay the WorldPop gridded data with these boundaries for each city, so we can derive population structures for every city globally. It's over 13,000 urban centers, from really small places that are towns up to megacities, as I mentioned earlier. And then when we calculate these demographic statistics within these cities, we can isolate out certain population groups. So we can calculate the proportion of the population that are less than 15. So as you might imagine, youthful populations in Africa is really highlighted there. And then older populations as well that may be more vulnerable to being trapped in place or exposed to flooding impacts. Working populations aren't shown here, but usually 50 to 60% for most cities. Does vary up and down a little bit in the case of Doha and examples like that. And so being able to kind of segment these out and look at different groups gives us a better picture of what climate impacts might be like. And so to add our climate impact data, we've mostly been focused on some of the demographics, the global urban demographics so far, but we're starting to weave in some of this climate information. We're looking at extreme urban heat exposure. We calculate this as a number of days per year that exceed a certain threshold using wet bulb globe temperature, whether that's 28, 30, or 32 degrees. And then we're starting to think about adding in flood data. As many kind of alluded to, flood data is pretty difficult to pick a good data set. At the moment, I'll be presenting results with the Dartmouth flood database, which is an archive of flood events and kind of hand digitized polygons to show the extent of flood. But there are gridded products that are available that we're exploring integrating into our data set at the moment. And so we can turn these flood events, we know the duration of the flood and the extent of it, and we can turn that also into a number of days per year on average that a certain location may be flooded. And this is what the map's like at the urban level. So the mean number of hot days per year over 30 degrees is pretty highly concentrated around the subcontinent. We can see over 80 to 90 days per year exceed thresholds. Equally, flooding is a little bit more dampened, but again, kind of concentrated around the same region. So we know people in these cities are exposed to dangerous climate conditions, but what we don't know is what the demographics look like, what the certain age sex groupings look like. And so adding those two together, having a look at young age groups, working age groups, and older age groups, and their kind of coupled exposure to these hazards, we can start to build a picture of which cities may be more vulnerable and which groups within those cities may be more vulnerable as well. And so this is a log scale along the bottom. So very small changes in patterns can be quite big impacts. But we can kind of see the impact of age-sex structures coming in here. If you think about Africa with a youthful population, the impact of older age heat exposure in terms of mean person days, so the number of people that are exposed to these is typically a little bit lower. But as we change region and as we change demographic structure, this varies. So it's kind of useful to look at these in aggregate. It gives you kind of a general idea of what regional demographic structure looks like. But sometimes it's nice to dive into specific examples. So I picked out two cities, Panjgur in Pakistan and Naples in Florida. Very different examples, but they have roughly the same population and they have roughly the same exposure to extreme heat conditions and flooding on average per year. But they have very different age-sex structures. And so in Pakistan, for example, we have a really youthful population. So 43% of the population is grouped in this 0 to 15 category. Compare that to Naples, it's 17%, but there's a lot more older people living there. Hurricane Ian passed through Naples in this fall, trapping a lot of people and having devastating impacts. So we think about this older population, if they need mobility aids and they struggle to move around in the event of a hurricane or a flood or something like that, they can be trapped in place and therefore impacted more severely. And so to kind of bring it back together, we know that population is increasing and becoming more urban. We know that climate change is threatening people. We know that certain demographic groups are more vulnerable, and these new data sets from WorldPop and kind of aligning those and synthesizing those all together allow us to draw better insights into what these impacts might look like across different demographic groups. It gives us more information about people that are exposed. It helps us to build resilience. If we know that old people in Naples, Florida might be more vulnerable, we can build resilience and kind of capacity there to deal with future threats. So as I mentioned, this is kind of new work we're involved in. We've mostly been focused on the demographic side of things, but we're starting to integrate more gridded flood products as well. The data set of urban demographic variability we're hoping to publish through CDAC, and hopefully that will be available for you all to use as well. But we'll be presenting more results of this as we kind of dive deeper in. So I'll leave it there, but happy to take questions at the end with the others. Thank you.
Okay, good morning. My name is Felicia. I am a Master of Environmental Studies student at the University of Waterloo. And today I'm going to be speaking about the 2021 atmospheric river flood event that occurred in British Columbia, Canada in the fall of 2021 that has really influenced flood adaptation and resilience planning in the region. Before I begin, I just want to acknowledge the ongoing support of my supervisor, Dr. Brent Doverstein, who's here in the audience today, and also the broader Living with Water project that this research is situated within. So I'm not going to go into a deep dive about methods and theory. I just wanted to highlight that I did fieldwork in the summer of 2022 and conducted 30 semi-structured interviews with policymakers, politicians, practitioners, and emergency management and disaster risk reduction professionals. So just situating where my case study is located, it is right near the Canadian and US border, just north of Washington. Sumas Prairie is a rural agricultural area of Abbotsford, BC, that's located in the Fraser River Basin, which is the largest watershed in BC, and is really at the confluence of 4 major rivers, the Fraser, Nooksack, Sumas, and Chilliwack rivers, although some of those connections have been heavily altered and modified, as we'll see soon. So really, when we're thinking about flood management in this region, there's a heavy transboundary and regional context that adds a lot of complexity. So Sumas Prairie is situated on the unceded territories of the mainland Coast Salish peoples, the Sumath, Matsqui, and Lekamel of Stalo Nation. Sumas Prairie, pictured here, is the Sumas Lake, Sumath Oksata, which was drained by the settler community in 1924. And without that colonial legacy and the drainage of Sumath Oksata, there would have been no flood impacts in Sumas Prairie today. So I think that's a really important place to start the conversation when we think about which values are being prioritized within the floodplain. So prior to drainage, Sumath Oksata was a tremendously biodiverse lake, and during exceptional flood years, such as in 1903, the lake could expand to over 30,000 acres and a depth of 31 feet. So you can see why the loss of such a lake would have had such tremendous impacts for ecological and cultural values in the region, for food security, especially for the local First Nations, and for natural flood mitigation from the Fraser and Nooksack rivers. So today, land use in Sumas Prairie consists primarily of agricultural and rural residential dwellings. Approximately 3,300 people live in the prairie. Abbotsford is also located within the Fraser Valley Regional District, which is one of the most agriculturally productive regions of the province. Even though it's only encompassing about 2% of the arable farmland in BC, the agricultural sector employs nearly a quarter of all farm workers in BC and about 15% of all farm operations in BC. So it's really a tremendously economic and agriculturally productive area, but that really comes at the expense of a very extensive flood mitigation system. Sumas Prairie relies extensively on dikes, diversions, canals, ditches, and a pump station, which pumps 2.3 million liters of water per minute from a drainage area of 95 square kilometers. And if that pump station were to fail, which it almost did in 2021, even without any influence of flooding or extreme weather, that previous lake bed would naturally refill within 2 to 7 days. So essentially, the lake bed has to be pumped in perpetuity to maintain the current land use. So in November 2021, BC's unprecedented season of climate-related disasters, which started in June with a really deadly heat dome and then a wildfire season that led to the loss of an entire town of Lytton, that all culminated in a series of atmospheric river events or extreme rainfall events that led to catastrophic flooding, debris flows, and erosion across the province. 17 regional districts and 60 First Nations were affected, and nearly 18,000 people were either displaced or under evacuation order. During this time, 5 people lost their lives, and over 640,000 livestock also perished. Additionally, every single major route going into the Lower Mainland and Fraser Valley, which, if you're familiar with BC, that's home to Vancouver. It's our most populated, densely populated, and economically significant region of BC. That was all blocked by landslides and road washouts, as you can see that middle photo there. So the event was really significant for the region. There was over $9 billion in estimated recovery costs, $625 million in insured losses. up to an estimated 5 billion in uninsured losses and up to 1.5 billion in economic losses due to supply chain and labor disruptions. So the event was really a wake-up call for BC that if we continue on the pathway of investing solely in hard infrastructure solutions and taking a really fragmented and reactive approach to flood management, we're going to continue to be stuck in the same disaster response and recovery cycle. I don't think I need to explain to the folks in the room here how fundamental disasters can be in shaping policy priorities, political will, and public risk perceptions. But the majority of my participants felt that the disaster had acted as a significant focusing event that highlighted the deficiencies in the status quo. So Sumas Prairie, like I mentioned, it's a very rural area of Abbotsford. It was one of the most significantly impacted areas in the disaster. They experienced a double whammy from the Nooksack and Fraser rivers, which typically don't flood at the same time. Usually the Nooksack will flood in the fall due to precipitation related challenges, and the Fraser River experiences more of that spring freshet snowmelt risk. But because the storm created high water conditions in both rivers, they weren't able to pump and drain out the water that was overflowing from Washington in the Nooksack out through the Fraser. So that led to the water pooling behind the dikes, led to some dike breaches, and a greater extent of damage there. In response to the disaster, the city put forward a series of proposed flood mitigation options that I'm just going to walk you guys through. They held their engagement session, which was a public information session, 2 of those, and 2 online surveys in April 2022. And then from that feedback, supposedly, they then proposed a preferred option to council in June 2022. So it was a very rapid engagement session. There have been a lot of criticisms about the city's approach throughout this whole process, particularly how the quote unquote build back better components were essentially recycled status quo propositions from decades prior, how the city went through a really rapid and tokenistic public engagement process that didn't really give the public much agency to engage in long-term community visioning. And importantly, the city did not collaborate with other watershed stakeholders from the onset, including the First Nations, who would be directly impacted by proposed diking changes. And there was there's a lot of competing values and ideas of what people want the future of this area to look like. Particularly, there were calls from some folks calling to retreat from Sumas Prairie and restore the lake bed either partially or fully to its former state, which of course, that idea in itself is very complex. There's a lot of complexity behind it due to how economically and agriculturally significant that land is. Since then, the city of Abbotsford has taken a step back in their initial proposed plan, largely in part due to efforts by other stakeholders, such as the First Nations, the province of BC, and advocacy organizations who are seeking to develop a better way of governance moving forward that looks at more watershed scale governance rather than each singular jurisdiction doing individual actions. So I'm not going to spend a lot of time on these maps, but these were the 4 options that were proposed initially to the public. The first 2 options were pretty much just status quo if nothing was done, aside from upgrading the redundancy of the pump station, so adding another generator, stuff like that, as well as potentially adding a second pump station in the area. Option 3 and 4 were the quote unquote build back better options, of course taking that claim with a grain of salt, because there's been a lot of criticism and concern about build back better for whom, with what values, and how. But the thing I wanted to mention here is this is the first place on paper in the plan where Abbotsford starts thinking about what potentially restoring part of that lake bottom could entail. Here they have it as an expanded floodway and storage area. Option 4, again, just an extension of that, but adding 3 additional pump stations to the plan, so a total of 5 pump stations in that area, as opposed to the 1 that is there currently. And after those 2 months of public engagement, the council approved a preferred plan, which incorporated the favored elements of the previous draft. So there's elements of dike repairs, modifications, setbacks, and also raising infrastructure, as well as creating some sort of new storage area, but it wasn't determined specifically where that was going to happen at the time. And last week, the city of Abbotsford just released a new iteration of their plan that now explicitly mentions language of retreat, protect, accommodate, and accept risk, as well as adding a temporal dimension to what dimensions are being prioritized immediately, like that pump station resiliency, as opposed to longer term conversations that need to happen more meaningfully and in collaboration with other watershed stakeholders and the First Nations. Since the initial plan was proposed out to the public, Abbotsford has now signed a memorandum of understanding with Chilliwack, which is a neighboring municipality, Samath, Matsqui, Lacamel, the First Nations, and the province of BC, to collaborate and develop a better way of working together moving forward. In this new Sumas River Watershed Flood Mitigation Collaborative, the province is acting in a convening role, and the local First Nations have been at the forefront of advocating for watershed scale governance. There's been a lot of grassroots, bottom-up advocacy efforts as well, just trying to get people to reframe values and how we approach watershed governance in BC. As well as this, there's been a resurgence of transboundary governance and collaboration with Washington State, Whatcom County, and tribal leadership through the Nooksack Transboundary Flood Initiative. So this was released last week and totally changed my entire presentation on the fly. So there's a lot of developments. It's a very dynamic situation right now, and a lot of changes happening as they continue to move forward with this collaborative process. So the last thing I just wanted to touch on is Whatcom County and what they're doing over there. I'm personally very excited about this enhanced collaboration with partners in Washington, because the folks in Whatcom County have been working on more holistic and integrated floodplain planning since back in 2016, when they began a values-based integrated planning model. Whatcom County also has been working with buyouts and land acquisitions for quite some time as a tool to reduce flood risk and expand and restore the floodway. And they were able to expand their buyout program and gain funding as a result of both COVID as well as the 2021 disaster. So in conclusion, there's a lot of lessons that the city of Abbotsford can learn from enhanced collaboration with Washington and Canadian partners, particularly as it relates to expanding that solution space of what is possible beyond just hard infrastructure, and instead moving to more of an integrated and holistic watershed planning model, where land acquisition and floodplain restoration are also incorporated as adaptation tools, not just modifying dikes and pumping infrastructure. So again, it's very dynamic and still changing, so it'll be really exciting to see what happens in the next couple of years. Thank you.
Can you see my slides now?
Yep.
Great.
That's good.
Hi, everyone. Good morning. And thank you for being here. First of all, I want to acknowledge the courage that it takes to be in an early morning session at a conference in the city that never sleeps on a Friday morning. So thanks so much for being here with us today. And apologies, I was supposed to be there with you and I had to stay in Boston to take care of some health issues. So that also leads me to acknowledge that right now I am in the unceded territory of the Wampanoag Nation. And yeah, very, very happy to be here, and thanks so much for allowing me to participate in this panel. So very quickly, my name is Lydia Cano. I'm a PhD candidate at the Massachusetts Institute of Technology. And this work is a combined project with Dr. Han. He is an astrophysicist at Princeton University and couldn't be here today. And the purpose of this project was to understand whether the implementation of what are considered today flood adaptation measures that are recommended or best practices, I guess, as considered as best practices for flood mitigation, are delivering benefits in reducing flood losses for communities equally or differently. So in other words, who are the winners and losers? So the way we do this is we use the national, the NFIP data set that contains flood claims that have been paid after a flooding event has taken place across the US. The control sample are all the communities that are in this data set, and the treated sample are those communities that actually got in this program called the Community Rating System that probably many of you are aware of. So this program encourages community participation in flood mitigation and offers a series of activities for which if communities implement this kind of a state-of-the-art best practices for flood mitigation, then they get a series of points, and in exchange, they will get discounts on their insurance flood rates. So that's the orange dots. And the way we approach this is we try to calculate the conditional average treatment effect, like you would do with many econometric approaches. But in this case, we use neural density estimators with normalizing flows. And just very simply, this is kind of one type of what we call these days deep generative models, like ChatGPT, like DALL-E, and all these other models that are like always in the newspapers these days. Very simply, the outcome that we look at is the total insurance claims in dollars per policy. And these claims are in particular focused on paying for losses that derive from damages to buildings or the contents of buildings. So upfront, I want to say and highlight that what we find in this study is only related to damages that take place in buildings, and this is not reflective of all other sorts of losses that take place after flooding and that communities suffer after flooding. And we look at this outcome in terms of several covariates, including the average monthly precipitation. And in this case, this average monthly precipitation refers to the precipitation during the month of loss, the flood risk score, the median household income, population, education, and renters fraction. And I also want to stress that the analysis was done at the zip code level to try to obtain the maximum granularity. This is a little bit more of details of how the methodology works, but really what I just want to emphasize is that being a non-parametric approach, we can actually estimate the treatment effect for any level of a covariate. So this is kind of how overall the results could look like. You can see that the red means that the flood claim losses diminish in an area where the treatment is applied, while if it goes toward blue, it actually increases. So you can see here that instead of a linear model or a log model where you have a predefined shape of what your effect is going to look like, here you see the treatment effect at every point of a particular covariate or a relationship between two covariates. So in order to, there's many findings in here, and I'm not going to unpack everything, I promise. It's a long day ahead. So I'm just going to try to slice these results in a few ways so that we can see some of the findings, not all of them, and I'm happy to discuss later and share the paper once it's published to discuss more in detail some of these trends. So the way we slice the results is by looking at the typologies of zip codes and on the basis of three characteristics: population, income, and diversity. And so we, doing a permutation of these three characteristics, we obtain 27 typologies of zip codes. So this is how the results would look like. A mess. This is, I do not recommend to present this in a conference. But I just wanted to show how, this can at least allow us to see that a trend may not be upwards or downwards only, or it may vary across each point of a covariate, and that can give us a sense of whether, of how the treatment operates depending on a particular covariate. So in one of the trends that is very clear from looking at this is that claims actually decrease the most for highly populated communities. And we can see this across the entire, sorry, I'm trying to put the pointer, right? It's fine. So you can see that below the graph is mostly orange and above is mostly blue. So actually claims increase particularly for low population, diverse and poor communities, while highly populated communities are the ones that seem to benefit the most, or like see the claims decrease the most. If we pay particular attention to precipitation, we can see that the treatment effect is most noticeable at higher precipitation in the month of loss. This is important because we look at the precipitation, the average precipitation that happened that month, to understand whether the compounded amount of water, I guess, or rainfall has an effect on the effect, I guess, of the flooding or on the flood losses. And we can actually see that the treatment seems to be very responsive to higher precipitation overall, except from a couple of exceptions that we will discuss later. So we see that claims actually increase with precipitation for diverse, rich, and populous communities. If we overlap these data points with a map of the US, we actually can see that this overlaps precisely with big cities. I don't have the map here, but the main hypothesis that we have here, and there is already many studies looking at the effect of impervious surface, is that the measures that this treatment or this program proposes in particular are not able to respond, are very well equipped to respond when there is not a lot of compounded rainfall, but they are not responsive when there is compounded rainfall and the impervious surfaces are high. So this can lead to maybe rethink some of the requirements that certain communities may need to pass in order to access, or in order to get the benefits deriving from this program, such as, for instance, prioritizing the reduction of impervious surfaces over other measures. Another interesting trend is education. So we see that actually claims decrease with educational attainment, but this is mostly until the 40% mark. After that, we see kind of a slight increase in claims. There is several reasons that can lead to this, and one of the hypotheses is that the program in itself has an educational component that explains how the program works and also how to succeed in applying for these flood claims and obtaining the payments. So it may be that as the education fraction increases, the population is more able to access these resources because they are able to access more of these type of sessions or informational sessions. And this component may also be able to actually explain how overall, and this is, I'm just taking one of the covariates, but actually this happens over all the covariates. Claims actually increase overall for diverse, poor, low population communities. So there is already a lot of literature showing how these type of communities actually have been traditionally underpaid in their claims traditionally for the same level of flooding and flood risk have received less payments after a flood has taken place in their community. So this may be showing actually that the program is able to overcompensate or like compensate for that historical underpayment of after a flood loss, because otherwise what we would expect is perhaps a little bit of an increase in flood claims, although in general we would expect that the treatment has effect or not. So if it doesn't have an effect, it may be like 0 or like a little bit above because of this kind of educational effect. But we wouldn't really expect for the treatment to, you know, cost like a $600 per policy increase after the implementation of the program. In the interest of time, I'm going to skip over these couple of ones, but another trend that we find, and that is also in tune with some of the things that are discussed in the panel today, is the issue of diversity. So we find that there is a consistent gap across all of the covariates between low-income zip codes that are less diverse and that are more diverse. So actually, the less diverse seem to find more effectiveness in their in the treatment. There is already a body of literature that has shown in the past that these communities, some of these communities are actually disproportionately affected by some flooding events in the U.S. But the good news is that they also get more benefited physically. I mean, affected physically speaking, and they benefit the most. But there is also some evidence that suggests that there is correlation between the type of activities that are implemented in low diverse communities and high diverse communities seem to diverge a little bit, and it will be interesting to explore whether this divergence in treatment effects is due to the selection of the type of approaches that are taken when entering the program. And I just want to leave you with a few conclusions for today. One is that with this study, we can see that this program and the state-of-the-art flood management interventions that it proposes actually decreases overall flood losses. However, the effectiveness varies widely across community typologies. And this is very important if we are hoping to design policies for flood mitigation with a climate justice lens. So it will be important to tailor adaptation interventions in ways that can benefit the typology of community, and also maybe reevaluate whether we need to require this one-size-fits-all kind of type of activities when we see that systematically don't work for a particular typology of community, since they might be investing in activities that don't work for their type of community just to be able to access affordable insurance. And also it will be important to be able to support financially communities that need to implement activities where we see that the activities work and that they might currently not be able to afford on their own, because this is a program where communities can buy in or not, and so they need to have the resources for it. And finally, it is important to provide processes that are accessible so that communities can continue benefiting and hopefully get access to the funds that they might have historically missed on, and also to establish monitoring mechanisms that can avoid information asymmetries in terms of education, in terms of income, to avoid unintended unequal outcomes. So thank you so much, and I'm happy to take any questions afterwards.
Is it here? Jason is? Okay, Jason, if you are there and you want to share your slides, go ahead.
Great. Can you hear me all right?
We can hear you. Your slides are on. We can see kind of all of them on the left there.
Yep. How is it going now?
Okay, that looks great.
Wonderful. Okay, I'll go ahead and start then. My name is Jason Sauer. I am a postdoctoral research fellow with the National Science Foundation, currently based at Portland State University and Universidad Austral de Chile in Valdivia. And I'm here to talk about a paper I have currently in review titled Relating Social, Ecological, and Technological Vulnerability to Future Flood Exposure at 2 Spatial Scales in 4 U.S. cities. Which is the very, very boring technical name for the paper. And I wish I had renamed it, at least for this conference, using new nationwide pluvial flood estimates in the United States to consider managed retreat. These are my coworkers or colleagues and co-authors on this paper, and my correspondence email is at the bottom of the page there if you have any questions that I can't answer within the scope of this panel. So a brief overview on pluvial flooding. You've probably been in previous pluvial flooding sessions, just in case you haven't. So flooding in general tends to be most expensive and damaging in cities. And pluvial flooding is a major form of flooding, particularly in cities. And just as a review or a reminder, pluvial flooding is flooding that occurs when the rates of precipitation in an area exceed the rates at which the landscape and the stormwater management system, in the case of cities, can remove that water from the surface. So it tends to increase in depth up until it becomes a nuisance or a real hazard for urban areas. And it can also interact with other forms of flooding, such as storm surges, fluvial flooding or riverine flooding. And so you can see this sort of interaction with pluvial flooding and some more coastal flooding here in Baltimore, Maryland in 2019. A key feature of pluvial flooding is that it is ephemeral generally and not permanent. It may last a couple hours, but the effects may last days, weeks, and months if it tends to, or if it accumulates in low-lying areas with poor drainage. And this ephemeral nature is probably why it's not necessarily or often considered among other sources of flooding when talking about managed retreat efforts. But pluvial flood exposure may increase or decrease in cities in the United States and around the globe in the future, depending on prevailing climate patterns and depending on development decisions by cities and urban areas. And just a quick review on pluvial flooding. So most studies that look at pluvial flooding vulnerability in particular tend to only examine one spatial scale. So like they pick one spatial unit like the census block group in the United States, and I'll talk more about that later, and only consider flooding at that single scale. And they tend to focus on historical or present day exposure rather than looking at estimates of future pluvial flood exposure, in part because pluvial flood models are much more recent and much more recently becoming more robust. So there just hasn't been as much opportunity or time to look at these future pluvial flood risk estimates. And then these studies also tend to focus on single case study cities as opposed to examining nationwide pluvial flood risk, again, in part due to data limitations. The spatial scale of these studies is very important, though. In the United States, a really common one that we use is the census block group, which is the smallest spatial unit provided by the American Community Survey. And the census block group usually contains between 600 and 3,000 people. On the right here, you can see in these orange polygons, the census block group overlaid across the neighborhood of Northwest Portland. And from the scale on the bottom of that image, you can see that stretches 1 kilometer, that top census block group stretches, over 2 kilometers, but some of those more central areas where the population is more dense are less than half a kilometer across. So there's quite a bit of spatial variability in a census block group. An advantage of using census block groups is that they're available for every city in the United States, which allows for comparative studies nationwide. And they are available for quite a long period of time, over a decade in most cities. And you can use that to create 5-year averages and do sort of temporal studies of vulnerability and demographic groups in the United States. But a con, especially with pluvial flooding, is that there's a spatial mismatch with the hazard, which varies over a distance of a couple of meters, as well as with the actual location of housing, so the places where the demographics are representing. And I'll show that on the next slide here. Another alternative spatial unit to use is one of the tax parcel, which is sort of at the spatial scale of a single or multi-residence building, plus the lot that it sits on, which is what we focus on in this study. And so you can see on the right, the tax parcels of this area in turquoise and the census block group in orange in Northwest Portland. And again, looking at that top census block group, you can see that actually most of the residences are concentrated in a very small proportion, particularly in the southwestern part of that census block group. So when you have the demographic data or the vulnerability data of different marginalized groups of the census block group, it may not be representative of the whole area, or you may not need to focus your efforts on that whole area. So PRO is, again, a better spatial match with hazard as well as with buildings. And that allows for better targeting of mitigation strategies excuse me. But a con of using this data is that, they're really difficult to obtain in cities in the United States. We, in our research group, have tax parcel data in part just due to personal connections and long-time collaborations within US cities. These data sets are often incomplete. So some cities may collect data that others don't. So that makes a comparison between cities rather difficult. And there's limited details in these tax parcel data about residents and structures, in part due to privacy concerns. Temporal scale is also a really important consideration for pluvial flood risk studies. So most studies only consider past or present day flooding, but anticipatory governance and things like managed retreat, buyouts, whatever, tends to require consideration of future flood risk in order to plan these managed buyouts or managed retreat that can take decades to actually carry out. And just as a reminder, future inequalities or environmental inequities are informed by past and present day decisions. So, past housing decisions such as redlining in cities and present day housing decisions that tend to favor, higher end luxury construction. There's still plenty of discriminatory housing policies in the United States and elsewhere that will be driving future inequalities and injustices. So it's important to think about future flood risk and pairing that with potentially these future demographics. The questions that we asked in our study, in particular, the first one being just about, well, what happens when we mess around or when we kind of toy with scale and compare that to high resolution flood data. So we asked, how do parcel scale future flood exposure data correlate with parcel and census block group scale? That's what the CBG stands for, vulnerability indicators within and among cities. And then the second question that we ask are, where are the areas of high future flood risk or high change in flood risk in cities? Just trying to see if we can see any sort of general spatial pattern within them. The study cities that we looked at are these four here: Portland, Oregon, Baltimore, Maryland, Phoenix, Arizona, and Atlanta, Georgia. And they're on four very different parts of the United States. And this is the land cover maps that you can see in the non-blue coloration in the middle there. I'm only going to talk today about Portland and Phoenix due to lack of time. But these cities are from four different very climatic regions, but they all share in common recent and large historical and present, recent and historical very large pluvial floods in these regions. But most importantly, we have tax parcel data for them, so that makes them comparable. The flood exposure indicators that we looked at were from the First Street Foundation. If you've been on Realtor.com or Redfin.com in the last, I think, 5 years, something like that, you may find that they have what is known as a flood factor score on housing real estate. And the flood factor score is an index put out by the First Street Foundation for every parcel of land in the United States, assessing future flood exposure. And you can see in this image here, or in this graphic here, so you have the 30-year cumulative chance of flooding along the x-axis and the depth of flooding to 24 inches and beyond on the y-axis. And to be clear, the conversion between inches and centimeters, I believe that is about 60 centimeters of flooding at that 24-inch point. The important takeaway here is that the cooler colors and lower numbers are lower flood exposure, and the higher numbers and hotter colors are greater flood exposure. From that data set, we also are able to calculate what we refer to as the change in extreme flood exposure, which is the probability or the difference in the probability of flooding to 15 centimeters in 2050 minus the probability of flooding to 15 centimeters in 2020. 15 centimeters was like the smallest, so they have increments of 0 centimeters, 15 and 30. We looked at 15 centimeters as the threshold because that represents a depth that becomes a hazard or nuisance to pedestrians in an area. The vulnerability indicators that we looked at are these here. This is a subset of all the different vulnerability indicators that one could look at with regard to flooding. But based on previous work, we wanted to compare this work to the previous work that we've done on present day fluvial flooding that used these particular indicators. The indicators here that are outlined in this blue color are available at the parcel scale. So redlining, building value, green cover, and building age. And the rest of the indicators are available at the census block group scale. So when we are looking at parcel scale results, we're only looking at those 4 outlined indicators there. When we're looking at census block group levels, we're looking at all of these indicators, including those parcel indicators, which were averaged to the census block group scale. And so the methods that we use are pretty standard regression methods. So, for global regressions, we used ordinary least squares and Spearman's rank. And for spatial regressions, we looked at spatial lag and spatial error. And we used exposure and vulnerability indicators at these 2 different scales, the parcel and census block group level. And so I'm only going to have time to go through 2 of the cities here. I may actually only go through 1 based on limitations of time, but we'll see. So again, so this is looking at Portland, Oregon. The top image is a flood factor. The bottom image is of the change in extreme flood exposure. And this is at the parcel scale, which is why it's relatively difficult to see, but we tried to do the colorations in ways that you would at least be able to see the areas of high flood factor and high change in extreme flood exposure. And you can see, or one of the patterns that we notice here is that the areas of higher flood factor and greater positive change in extreme flood exposure tend to follow historical and present day waterways in the cities. These may be buried streams, they may just be inactive streams during most of the year, but they are in the future going to be sites of substantial flooding. And then one of the other critical features that we see is flooding usually at the base of these areas with high slope, and particularly in that southeastern part of Portland, which is where there are a lot of cinder cone features, these small mountain features within that region. And so there's massive amounts of flooding that occur at their bases. If we scaled it up to the census block group level, which again is the unit that most of these studies are done, it's much more difficult for me, at least, to identify that what I'm looking at in terms of the patterns here is proximity to historical and present day waterways, particularly in the central part of the city, but we do still see increased risk at the base of these mountainous features. In Phoenix, Arizona, real quickly, we see the same sort of pattern along those historical waterways, particularly a lot from the north to the sort of middle west part of the city. And then interestingly, Phoenix is the only study city that we looked at that really had large areas, particularly at the census block group level, that would have reduced flood exposure, which is largely owing to patterns of precipitation and climate change in the region that are particular to Phoenix. If we look at all of the statistical analysis that we did, which I certainly don't have time for, let's just look at these 2 values available at the parcel scale. We can see that building value and green cover, for example, were negatively correlated with flood factor in both Portland as well as Phoenix. And the change in extreme flood exposure, though, was negatively correlated. I'm sorry, building value and green cover were negatively correlated with change in extreme flood exposure in Portland, but positively correlated in Phoenix, indicating that these single case studies may not necessarily be as widely applicable as previously thought. If we scale these results up to the census block group scale, we actually see quite a few results. Significance drop out. We see no significant results for building value and flood factor in Portland. or green cover and flood factor in Phoenix. And in terms of the change in extreme flood risk, we actually see no significant correlation between building value at all in either, and change in extreme flood risk in either city. The main findings, as far as we view them, are first off, that future flooding was often most severe or changed in historical waterways, and again at the base of these mountain features. That the correlations changed direction or lost significance when scaled up to match common vulnerability indicators, indicating that spatial scale really matters. And 3 areas not currently at risk of pluvial flooding may become at risk under future climate conditions. We did see some historical waterways that maybe were not problems in previous pluvial flood analysis that became problems under these future climate conditions. Policy implications that we see are potential restrictions to construction should be considered or potentially expanded along historical waterways. Buyout programs should potentially be considered for homeowners in areas of high flood factor or increasing exposure to flooding, again, along these waterways and along the base of these mountains. And projections of demographic changes would be very useful to ensure that relocation efforts and managed buyout, whatever that a city pursues, does not actually create inequitable exposure of marginalized populations under future climate conditions. And that's all for my time. I'm happy to answer questions. This is acknowledgements to the various funding agencies that helped fund this research. Thank you very much.
So we have a little bit of time for questions. I don't know if the other presenters want to come up here, and if anyone has any questions, then fire away.
Hi, thank you all for your presentations. Very interesting work y'all are doing. This one's a little bit more for Lydia, though I'd be interested to hear what other folks have to say. I did my dissertation at Brown focusing on the community rating system, actually, and if there's one takeaway from my work, it's that participation in the program reflects administrative capacity and not actually undertaking these flood mitigation activities. And so I'm wondering where an examination of mechanisms or how you're sure that CRS is actually provoking these changes versus it being a spurious correlation in your results. So I was wondering if you could speak to that a little bit.
Thank you so much for that question. And this is something that we have contemplated as well. But the fact that, well, first of all, I would love to see your work, and I haven't found any very complete a database where I can actually see the full administrative capacity complemented with also grassroots level community response capacity. And so we have not considered that into the study, but one of the things that we see is actually that not necessarily only highly populated communities or high income communities that have been in the literature portrayed as being the ones with more administrative capabilities are the ones that benefit from the program. So this led us to kind of be at peace with this potential spurious correlation, but always, like open to recalibrating and including more data. So I would love to see your work as well on this. Thanks.
Hi, this is a question for Andrew.
Yeah.
You alluded to using the World Pop data to look at migration versus national trend. And I was wondering if you could address migration and exposure and just,
Yeah.
on that.
So that's something we're being a little cautious with at the moment. So with population pyramids through time, we're able to derive a number of different things. And because World Pop has the 0 age category, which is the number of births per year, We have the number of births. What we don't have is the number of deaths. And so we're using an approach at the moment to use age standardized national death rates, which obviously vary across rural and urban gradients. So given those assumptions, we can roughly approximate the number of deaths in each urban settlement per year. And so using the births and deaths in conjunction with the total population change, we have the balance equation. And so we know whether population changed as a result of natural increase or the remainder would be migration. And so as part of kind of our first section of this analysis, we're just focused on the demographics. And so we're looking at the patterns of urbanization for all these cities, whether they have grown or whether they have declined, and whether that's natural change or migration. We, in theory, are able to kind of compare that with the climate information as well. It's mostly migration stocks, so we don't know where these people came from. We just know that between 2000 and 2020, migrants were added to a certain place. And so we can kind of piece together a story that might explain migrant populations and their exposure to whatever kind of climate conditions you'd want to look at.
This is a question for Felicia. The Canadian system for funding managed retreat is quite different from the American system. I don't even know if we could call it the Canadian system, but I'm wondering, since the idea of retreat in your case study is all of 1 week old, how you might, in a speculative manner, could you maybe tell the audience how managed retreat in your case study region could be funded? What are the avenues available for funding? And, is that a local, provincial, or federal responsibility?
Yeah, so Abbotsford's plan is completely reliant on provincial and federal funding. Right now, Canada does not have any sort of standardized buyout program the way that FEMA and HUD has here in the US. Right now, a lot of the focus is on the redundancy in the pump station, which they already had an infrastructure grant for that as well. But there's no mention of in any of the plans of how this is going to be funded. It's just broadly seeking support from the province and potentially through some of the disaster mitigation and adaptation fund that's being offered through the federal government. But those tend to it's more to do with infrastructure related funding as opposed to that managed retreat element. One of the things that I heard at one of the public information sessions is the idea of potentially buying back the land but then leasing it back to farmers, or compensating for a removal of structure, but still allowing that land to remain in that agricultural operations title, so they can continue to farm in part of that area, but they might have to change what kind of crop, or maybe change where their structures are on the property. But no mention right now in the plans of where that funding would actually come from. And BC and the federal government lack a managed retreat funding stream altogether. So.
Hi, thanks for your presentations. I have a question that is mainly related to Andrew, but also a little bit to Manny. So also because Manny was alluding to this as well when it comes to data uncertainties. So I was wondering, Andrew, especially with the data sets that you're integrating, the World Pop data, also the urban centers database, and then the different hazard data sets. What would you say, how reliable are your results, and how many uncertainties do you actually have in these results? And how confident are you in what you can produce with the data that we have right now at this level of analysis?
Yeah, thanks. That's a really good question. Obviously, when you're estimating population is one thing, but the age and sex distributions within a population is another thing. tying them to climate information again is another thing. So these kind of errors that are within the data sets can compound. We're at the moment performing some sensitivity analysis to see our estimates of migration, to see how accurate they are. We're able to ground truth with some information, mostly in the Western world, in the United States and in Europe. But when we're looking at small urban settlements in Africa, there isn't any information about them. So really anything that is available is better than nothing. Often those are on the front line of climate exposure. And so I think the last census in DRC was in the 80s. And so beyond that, there isn't any information about how many people are there or where they're distributed. So of course there are errors, but something is better than nothing. But we're hoping to kind of put some bounds on our estimates and be quite cautious about what they show. And being able to explain using gridded population data in a way that it isn't the exact number of people within a pixel, but it's all estimated, but can be useful with that context. Thanks.
I can also add on. So for me, well, I have to be very honest that I also don't know like how confident it is with mine, because particularly I'm looking into the global south. I'm really have like a hard time into finding data, and I'm just basically put whatever knowledge we have to combine them together. But like one of the experience that's not shown in this project, but actually related to my impact forecasting. So I actually built a tropical cyclone impact forecast for displacement risk. It's a prototype, and it's supposedly to be applicable in globally. So what we've done is actually, so we know like hazard, for example, the tropical cyclone forecast, there is uncertainty. Currently the exposure, like I could not tell like what's the confidence level. There's no information available. But like with the vulnerability function, the impact function I calibrated, there's also a bound. So what I've actually done also with my master's thesis student in verifying the forecast is that we made a global uncertainty analysis. So I mean, all this uncertainty, the three components, they interplay with each other. We did the Monte Carlo sampling and like doing many times and see where this uncertainty is attributed from. And then we actually able to at least extract some useful information that like, let's say like the forecast, from the meteorological forecast, the uncertainty dominates when let's say we try to predict an event that is like 3-4 days in advance. But of course, the uncertainty, you can also imagine it lies in the vulnerability function. So there is already a very important piece of information for decision making, that what you should consider at what time of the forecast lead time, like what you need to consider when you do resource allocation or outside like that. So yeah, what's going forward? Yeah, I mean, with this particular project, it's more like a test ground on a smaller scale and see how much we can resolve. I'm also started to think about maybe like we need some expert judgment on the bounds on the displacement data, but that one I will need the humanitarian organization to give me like certain bounds, and maybe we can still play around with all this uncertainty, sensitivity, and analysis, and try to extract information. But one thing I also learned is like, when we try to say like a hazard for humanitarian organization, it's probably 1 million people affected versus 2 million. You probably do the same thing.
I have a quick kind of follow-up question on that. Have you thought some about the definitions that you're working with for the displacement? So you mentioned like that there's different definitions and how much that could affect your results, and whether you could maybe explain some of the differences in the number by just who they're including in those estimates?
So, well, I can comment a bit more on the IDMC data. So there, like so there's a few problems when I do my modeling. I'm taking the tropical cyclone as example because I'm actually work with tropical cyclone more. First thing, it's between countries. Like some countries, for example, Philippines, they tend to evacuate a lot of people, and the evacuation is also counted as displacement. And some would also just count for like housing damages or how many people influxes to shelter house. So there's no time domain over there. I don't know how like this new fluxes of displaced people, how long they're staying, if it's just a one-day evacuation or they are long-term being displaced. That's already one of the challenges that when I'm dealing with the data. And the second thing is, yeah, there's a lot of also people like being affected of course, like we talk a lot about the immobile or involuntary, like trapped population. That is not being counted. And well, the next step forward, at least what I understand from IDMC side, is they want to push forward on the housing damage displaced. Because like, of course, like if your house is damaged, then it's most likely you're long-term displaced. They're trying to collect data on that side, but now the data size is still a bit too small for me to calibrate any kind of function. But I did a case run on Philippines. It does seem a lot better than right now the displacement.
So I think we're at our time now. So thank you guys all for coming, and I'm sure we're all happy to take more questions if you want to send them on the app or connect with us later. Thank you.